Hi everyone, welcome back to Hack the Platform. I'm Konstantin and today we're going to explore a very practical question: how should we load data in Power Pages using Liquid or the Web API? And before we start, please make sure to like, subscribe and leave a comment with your thoughts. Your feedback really helps me create more content like this. So let's start with some basics. Liquid is a server-side templating language. It runs on the server, fetches data, and builds the HTML before sending it to the browser. Everything happens sequentially on the server, and the browser receives fully rendered HTML ready to display. On the other hand, the Web API approach is client-side. The browser first loads the page shell, and then the JavaScript fetches data asynchronously from the server. This means we can progressively render the content while keeping the initial page loads very fast. The problem I often see with several customers is that they try to load everything directly into the browser, and in some real-world scenarios, that's tens of thousands of records. With Liquid, this can make pages take 20 to 30 seconds to load. We will see that today, and Web API loads the pages quickly, but if you fetch everything at once, it can still be slow. So we want to explore which approach works best and when. To make this concrete, I built a test page, also created a Dataverse table, where I added multiple of items. Then all these items are rendered as product cards, starting with 200 items and going up to 10,000 items. Now, obviously, nobody really wants to see 10,000 items in a user interface, but I've seen multiple implementations and problems where developers just load everything to the browser. The page interaction is fast once everything is loaded, but the initial load time is extremely long. That we will see today. We are going to compare two things here. For Liquid, we will measure Largest Contentful Paint, which tells us exactly when the main document object model content is ready. All the cards are pre-rendered on the server, and when document object model is delivered, we see everything. For the Web API, we'll use a custom JavaScript metric to see when all the data is fetched and rendered in the browser. This will be a combination of this metric and also of the Largest Contentful Paint. Largest Contentful Paint will be relatively fast in comparison to Liquid, just because only the empty HTML page with a number of JavaScript files will be loaded. The rest will be fetched using the Web API. First, let's load 200 product cards. With Liquid, the page renders in about 1 second. The Web API approach, where JavaScript fetches data after the page loads, also takes about, let's say, 1 second. So here the difference is negligible. Both approaches perform equally well for small datasets. Next, we scale up to 2000 product cards. With Liquid, the page load increases to about 2.6 up to 3 seconds, while the Web API approach takes around 2 seconds here. Here, the Web API starts to show a small advantage because the server-side rendering in Liquid has to loop through all the data and build HTML sequentially and without any asynchronous load and without any parallel execution. So everything happens sequentially, and thus we receive about 2.8, 2.6, so up to 3 seconds load with just 2000 items. Now let's push it to 10,000 items. With Liquid, the page takes, let's say, from 22 to 30 seconds to render. That's to load and to render. That's almost half a minute of waiting before the user can interact with the content. So it takes really long to load. Even if I load several times, it still will show me around, let's say, 22 up to 30 seconds. With Web API, the page loads the shell instantly, and the JavaScript fetches all the data asynchronously, as we can see here, in about 6-7 seconds. We can try it again. We can check the performance. So let's say in about 7-8 seconds, the data is loaded. That's also a lot, but this clearly shows that the Web API approach scales much better for large datasets. Now, let's quickly look under the hood and understand why Liquid and Web API behave differently. I'll highlight just a few key points, the full comparison with all details in the blog post link in the description. First of all, we're talking about, for example, synchronous versus asynchronous rendering. Liquid builds all HTML on the server before sending it, so the user waits for everything to be ready. Web API loads the page shell first and then fetches data asynchronously, giving the user something to see immediately. Parallel data fetching. In our case, it's not an option. I didn't use any parallel data fetching in the Web API, but even if I use that, Liquid executes templates sequentially, so multiple datasets cannot be loaded at the same time. With Web API, multiple API calls can run in parallel, speeding up the data load. Caching. Certainly caching. With Web API, JSON data can be cached on the client and also on the Power Pages server. And this allows repeated requests to be served faster. Liquid caching works a bit different, usually caches the full HTML pages, which is less flexible. So these points give a good sense of why performance differs. There are even more. For a complete table comparing aspects like incremental rendering, CPU usage, network payload, UX, SEO, and complexity, check out the blog post linked below in the description. And here is an important point. So Liquid is perfectly fine. So it's really good, but it needs to be used correctly. You don't want to send 10,000 records to the browser. In most real-world apps, user will filter or search, and you can pass these filter or search values as URL parameters to the server. And then the server will return a pre-filtered dataset. That way, the page loads fast, you leverage server-side rendering, and the user sees only what they need. The same principle actually applies to Web API. Don't fetch everything at once, load only what the user needs. And if large datasets are required, fetch them asynchronously in the background. So, to summarize, for small datasets, Liquid and Web API are both fine. For medium datasets, Web API starts to perform slightly better, however, Liquid can also show good results. But for large datasets, Web API is clearly faster and more scalable, specifically when you can show something to the user, either a spinner or show some a message that please, we are loading the data, wait a bit, and so on and so forth. With Liquid, you cannot show anything. The page is still not there and will only be there after 20, 30 seconds of waiting. The golden rule here is load only what the user actually needs. Combine server-side filtering and initial rendering with client-side asynchronous loading to get the best performance, perceived speed, and user experience. And that wraps today's session. So I'm Konstantin. If you found this useful, like, subscribe, and leave a comment sharing your experience. Check out the blog post in the description for the full table of comparisons and more details on these approaches. See you next time.